Hey guys, today is electromagnetism, lecture 6. We learn about today's lecture is relationship between electric current and magnetic field. Okay, let's see more. So you guys may know about this, right? We now exactly, not abstractly know about the current, but we kind of, kind of a abstracted, concept about the magnetic field. So let's see, okay? I will move on to the, uh, no, okay. So as you guys, here's a charge, here's a charge. So the charge is move, you know what I mean? The charge is move, we say current, right? Current, right? So this is where we get it, this charge from electrification, right? From outer energy. Yeah. So what I want to say is when we found was when we found was how we found the magnetic force when 80-20, yeah, maybe 80-20, the Ørsted found. Okay, I'll explain, look at that. There was a current is flowing here, but near there's magnet. And when the current is flow, the magnets rotate or move. So that time they realize that there's something force. Yeah, that is how they, find out the new force. We say magnetic force. Okay. So, okay. So what I mean is, let's move on here. So yeah, instead any tradings he found the magnetic force. So there's two scholars, Amperes. We are kind of familiar him, right? But Biot-Chaber's, we really don't know about it, right? But both of them are really great scholars. You know what I mean? So what they did was, there's, magnetic force happened, right? So, okay, let's one more thing we need to know. There's magnetic field, right? Magnetic field means, the space, you just try the space. Some space, the magnetic field, magnetic is like there exist, right? We say that space, we say, when the magnetic force is exists there, we say magnetic field. So they wanted to know how much of a magnetic force it is. Okay, so Biot-Chaber's laws generally use kind of a scientist or kind of a more, it's a kind of a hard math. So for the developer or scientist that they generally use. For amperes, so we are kind of familiar because uh like there's a conductor, right? Just straight conductor. So like this simple, simple stuff, we could check it. The current is, if we know current or magnetic field's direction, we could know about the other direction. Okay, I explain more. Let's move on. Okay. So I give you a question. Look at that. Here is the cause. Here is the result. Okay. We now know current. Okay. I will say current cause. Okay. Current cause and result is magnetic field. Just we say M. We know this, no? Yes. Right. What about this? If it's magnetic field, current. Yes or no? Yes or no? Yes or no? X or O? Yeah, of course, this is yes, right? You're kind of confused which one is that. Of course, yes. It could be also, it is also cause and it is result, okay? Two, I mean, it happened simultaneously, you know what I mean? At the same time. When the current is happened, magnetic field is also happened, okay? Magnetic is happened, current is follow. I'll explain more. Simple. Okay. Here's a big mirror. Mirror, I say mirror. I'm standing on here, right? And I could see me also, right? I will say this is a current me now, real me, and inside of the reflection part, I would say magnetic force field. Okay, so we are same, but the differences is a dimension, right? Look at that. If I, okay, this is for example what I now see my screen. I could see like a mirror. If I say like a hello also, it says also hello, right? If I disappear or come back, the same action is happened simultaneously at the same time. Yeah, that's it, current and magnetic field. Okay. And the last, yeah, that's all. Yeah, magnetic current, same but different dimension. Okay. And then let's move on. Look at that. As I said, here's the Maxwell's right-hand grip rules, and as we now well know about the Ampere's, right-hand grip rule. Actually, same. Now, because we have just straight, conductor. For example, look at that. This is current, right? The second picture, look at that. This is current. My thumb is here, right? So the rest of my finger here. So look at that, like this. From here, like this. First, I need to, same direction, the thumb. Like this or this, it doesn't matter. Just make it thumb is going up. And look at that. Yeah, look at that. This, right? I grab it. This is a magnetic field this direction. That's it. The Ampere's law. Or for example, the third even though this is a Maxwell's right hand grip, so but this is the same because we have a straight conductor. Look at that. We can see first of all the current's direction. Current's is look at that, as you can see. For example, current is flow like this, right? I will say this is forward. Okay, forward. And now my thumb is here, right? My thumb is here. We say here, this is the magnetic field direction, okay? So magnetic field is, as you can see, from this thumb direction is N, the direction N, because the magnetic field, as you can see, make it kind of a circle and come back and circuit and come back from N to S in, from N to S E. For example, if the current is like, for example, reverse way, I will say, before I did this way, right? But this time, this way, reverse, right? What about this now? The thumb is here, right? So the magnetic field is here, but this is N. From here, circuit, okay. This is magnetic field, okay? Okay, from here, kidding. This is S. This is N. That's it. I hope so you guys can understand everything. See you next time, guys.